still in auto advance.
Okay. My name's Trystan. I'm going to talk today about the Open Energy Monitoring Project. It's a project to develop open source energy monitoring tools. I work on it with Glyn here at the front, and it's an online project, so we work with a lot of people across the web. The energy monitoring part is about developing tools that can help us work towards sustainable energy in a way that adds up. So this is sort of inspired by a book by a professor from Cambridge University called David McKay, who wrote this book called Sustainable Energy Without the Hot Air. He created these sort of graphics here on the right showing how we go from where we are now to where we need to be in terms of sustainable energy. This stack here on the left is my use of energy. At the moment I've got 17% of my energy from sustainable sources, and that's mainly sort of green electricity from good energy, so that'll be from like a wind farm, and some wood heating from our own logs. But then we've also got lots of fossil fuel energy going in there, so a lot of oil for heating. We've got a really not very efficient oil Argo, which is heating the house. It's an old Welsh farmhouse up in the mountains of North Wales. So that's a large part of our energy use. Another part is the transport, so a little bit less than the national average, but still quite a lot for the petrol in the car. And the stack next to it is the national average, and the stack to the right of the stack is the sort of Centre for Alternative Technology target for where we need to get to. And it's really amazing how far we can go with the technology that is available. We can, on the heating side, we can reduce the amount of heat that we need to heat our homes by about 90% with modern insulation and draft proofing, and reduce the energy that we need for transport by about 4 to 5 times with electric cars and electric trains. So there's a massive potential of how much we can reduce the amount of energy we need to put in, and if we can then provide the rest with sustainable sources like wind farms and so on. But an energy monitor is there to first give you the information of where you are now, so work out how much electricity I'm using at home, or if you've got gas, you might measure how much gas you're using, and then also be able to optimize, say how well your heating equipment is working. So one of the most effective sort of sustainable heating systems is a heat pump, and I'll talk in a little while about using the energy monitor that we've been developing for optimizing the use of a heat pump. So the other part of the energy monitor that we're developing is that it's open source. So open source is about really encouraging people to, I'm sure we all know here, encouraging people to make and develop technology. It's a relatively simple action in a way, in that when you develop your technology, you release the design files, your CAD drawings, your source code online. And to make it effective, you do need to write some good documentation and really engage with building a sort of website and community around that, so that people can make use of it. But the result of that action of making the technology open source is, there's a whole load of benefits that can come from that. From being able to learn about how technologies are put together, and then being able to, once you learn, you can then develop those technologies further and create innovation, and there's all sorts of great benefits. So one of the inspiring things about the open hardware movement is some of the companies that have grown out of it, companies like Arduino, who probably like the poster sort of company of the open hardware movement, and also the the sort of foundation for a great deal, and probably like 90% of all open hardware projects. But we build massively on Arduino, so all our hardware is based on Arduino. There's also other companies that we in particular build upon, like G Labs, which is a company based in Belgium, I think. Netherlands. They do all sorts of sort of research into sensing and data logging type applications. So we've started a business around the project. It's the Open Energy Monitor Shop, so selling the energy monitor in kit form. There's also other businesses starting around the project. So and that's something that we really want to. The project is like an open research project. And we want to encourage several companies around that, either providing modules or doing things like energy consultancy type services. There's quite a few of those kind of businesses starting it. So this is the Open Energy Monitor system as it stands today. At the heart of the system here is the EmonCMS, which is like a wireless energy monitoring sensor node. We've got one here, I'll pass around. So it has 3 current inputs, so it can measure how much current you're using in your house, or how much electricity is being generated by solar PV panels, or whatever you clip the sensor around. It's a little inductive based sensor which measures the magnetic field around the wire that's carrying the electricity. So it's got 3 inputs to those. It's also got a voltage input, an AC adapter, so that allows you to monitor the voltage waveform of the mains. And combining that with the current measurement, we can measure real power and power factor, which is you get billed for real power. And the power factor is if you've got motors in your house, you'll have like a low power factor, or if you've got a lot of LED light bulbs and like switch mode power supply with laptops, you'll have a low power factor. But I won't go into that. No, yes. The EmonCMS can also interface directly with with some smart meters. So any meter that has a flashing sort of pulse output, so they might have some like flashing LEDs on them. And then there's some meters that have like an infrared port, an IRDA port, so specifically the Elster meters. And they allow you to, give a sort of serial output, which you can, which is actually a really useful way of getting the data, because it tells you exactly how much you've used, rather than, so if you turn it off for a bit and then take another measurement, it will still be, well, if you turn the EmonCMS off for a bit and the meter's still going, you can take another measurement and it'll still be correct. And then the last input it's got is temperature sensing. So you've got the one-wire digital temperature sensors, they're DS18B20s, and they're really neat little sensors. They have about 0.5 degree accuracy, and you can string them up as many as you want on a length of cable. So, what, is it 10 or 20 or?
Yeah, more actually.
Yeah. We tested it with about 12 and about 15 or so meters of cable length. So then the EmonCMS transmits that data wirelessly to any of the listening nodes. We've got this is the EmonCMS we've been passing around. This is the EmonCMS PCB. So one of the things I'm quite proud about is we've done the design in Wales, and we've recently got the latest batch of boards made in Wales in the factory near. Whereabouts is it?
South Wales, somewhere, I think. Yeah. One of the valleys.
One of the valleys. Cool. Yeah, so all the designs are all on a website called SolderPad, which is like GitHub but for hardware. And that's an app maker in the middle, which is the Arduino. So it's the Arduino chip. So you just use the Arduino software to upload firmware onto it, and so it's pretty easy to use. So the next unit is the screen. The backlight isn't lighting now because it thinks it's not, when it's connected to the internet, it gets the time from the internet. And if it's before midnight, if the backlight's off, after midnight, the backlight goes off. But it's, this is so you can program this to display any kind of information, so that how much power you're using, or I'll show you an example in a minute with if you've got generation equipment, or you could use it for a completely different project. So say you wanted to bring like Twitter messages onto it or something. It'd be great to see it used for some different applications. So the next part is it's got like a web connected base station, which essentially just relays the information monitored up to a web application that we've been developing called EmonCMS. EmonCMS is an open source. It's an open source web application. You can install it on your own server, very similar to like WordPress or Drupal. It's written in PHP, it's MySQL database. All the visuals are in JavaScript and sort of jQuery. And the focus is on. There are some other sort of web application service energy logging applications out there, like you might have heard of Cosm. This one takes a slightly more focused approach to energy monitoring and gives you a whole load of features to process the data as it goes in, so converting it into. So the EmonTech sort of measures every 5 seconds how much electricity you're using. But you might want to convert it into how much electricity you've used in a day, and it's got that kind of processing built in. It's also got some put a lot of work into the sort of visualization tools. That's also available to download from GitHub. One of the main features of it is a visual dashboard editor. You can draw sort of drag, drop, and resize, and sort of different types of dashboard styles that sort of animate, and so the hot water cylinder, so you can see what temperature might be. Hot water cylinder. So I'll talk a bit about applications that it's been used for. The most basic one is home electricity monitoring. For this, you only need the one clip-on sensor, and you just put that on where the electricity comes into the house. And you then push the data into EmonCMS, and you can sort of identify the parts of the electricity use that are like base load, which things like lights or fridges and anything that's sort of standby. That's the sort of browny green colour, and the sort of reddy colour here is the immersion meter, so you can distinguish between different uses of power. And this is the work of a guy called Mark Phelan, and he just contributed to the project. That's in there. GitHub pull request one day, and now we have this ability to do this kind of analysis. an energy monitor gets a lot more interesting if you also are monitoring, if you have some generation equipment like solar PV, like a solar PV system. So one of the things that's been missing from a lot of solar PV monitors, or at least the ones that you get, that you might get, the sort of standard ones that come with a PV system, is that they don't monitor how much energy you're generating at the same time. So you can't really, it's difficult to know, are you importing power from the grid, or are you exporting, are you using more than you're generating, and so on. But with this, you can put a clip on the power that's coming into that you're using, or the power that's coming into your house, and another clip on the PV, and you can make, the display's got like little indicators on it, little LEDs, and you can make them glow green if you're exporting power to the grid, and red if you're importing power. You can also post, again, you can put data online, and you can say if you have a few friends who've got some PV generation, you can do that kind of comparison to see, which one's performing best, or is there any problems with any of them. So another application, coming back to not so much electricity monitoring, but using it for working out how well sort of a heat pump is working. We've been working with a good friend of ours, and a heat pump expert in Mid Wales, who's sort of adapted the system for monitoring heat pumps, and that means you just use a few. You put in a lot of temperature sensors. You plug the temperature sensors all around the heat pump, around how the hot water out and the cold water in, and the air in and off. So different points on the heat pump, and you can use that as a sort of like a stent. John calls it like a doctor's stethoscope for working out whether how well the heat pump is performing. And you can create these really sort of complicated graphs, and once you get a feel for it, you can work out where things are going wrong and how that can be improved. And he's been installing them for quite a few of his clients, and he can then monitor the heat pump remotely and suggest improvements if he sees there's anything that can be improved. Another sort of diverse application of the monitoring system is for monitoring that it has been used for is for monitoring the temperature inside beehives. So there was a question as to whether, if you opened a beehive sort of, regularly, whether that would the bees would take a long time to recover, and they would therefore have like a lower honey yield, or they sort of affect them adversely. And we helped the local beekeeper test that hypothesis, and it's an interesting bit of work in that the bees managed to maintain this sort of core temperature of about 34 degrees, even if the outside temperature drops below zero. They're really good at keeping that temperature very stable. And I think they do this by beating their wings, or not sure how. There's one mechanism they do for heating, one for cooling. So they can, even if the outside temperature is much higher, they can bring it to a stable level. And the interesting thing was that they recovered their temperature after you opened the beehive. They recovered their temperature in a really short time, so it suggested that it might not. And if you can detect that in time and get out there ready to catch the swarm as it comes out, you can then create a second have a second beehive and increase the size of your bee colony. So that would be something that's really useful for beekeepers to be able to, they might get like an email or a tweet or something saying. So because the system is open source, it really allows it to be used for all sorts of different applications, and people are using it for university campus monitoring to brewery monitoring, and there was one email from a team that had used it for monitoring the power quality in this remote mountaintop observatory in Hawaii, which is quite sort of interesting. You can quite imagine that our kits were going out to these places to be used for these kind of applications. And also, because all the protocols are all open and you can pretty much write any protocol you want for the system, it allows people to develop other modules that will plug up to the system. So there's a really active guy called Martin on the forums who's developed a series of modules, like really small temperature sensors that you could plug all over your house to get the temperature distribution in your house. And like a Raspberry Pi breakout board. So I passed around the base station earlier, which is like an Arduino-based base station. But there's an effort going on at the moment to develop a Raspberry Pi-based base station. So that would allow you to run your logging server on the Raspberry Pi itself. So locally, you might have some kind of syncing to a remote server, so a Dropbox type syncing to a remote server or something. Another active project on the forums is an immersion heater. Is a sort of a unit for diverting excess electricity that you're generating from solar PV panels to hot water via an immersion heater. That's been a fairly active topic. 3-phase monitoring as well. So it's more than just developing this like an end product, an end technology. The project is more about developing like an open technology commons, so for energy monitoring. So a place where you can get information on how you build energy monitors from the sort of basic physics of AC monitoring to AC power to sort of sensor circuit design to building web applications. This is the Open Energy Monitor website. So we've got forums, all the firmware and software is all up on GitHub. Yeah, I mean, to conclude, but I mean, by building an open source energy monitor, it's sort of one example of an open source sustainable technology that you could develop. But we really like to see the potential of applying open source to sustainable technologies in general. So, because if you to build technologies that to solve these kind of sustainable energy type challenge, it'll be much better if we can share all the information about how we're developing the technology and how it be able to work towards sustainable energy in a more collaborative way, rather than sort of competing with similar products and reinventing the wheel and so on. So that's one of the sort of aims of creating an open project. Yeah, so thanks a lot.
Do you have any questions for Trystan?
What's a heat pump?
Ah, yes. It's like a air conditioner or a fridge running backwards. So rather than making a space cold, so think of a fridge, rather than making the inside of the fridge cold, it runs backwards and pumps heat from it. It makes sort of takes heat from the air outside and makes the house warm. And it's you put 1 unit of energy in, and it'll move 3 units of energy from the outside to the inside of the house. So it's like a 300% efficient electric heater, but it doesn't. It's not like violating the laws of thermodynamics or anything. It's just
That sounds cool.
You can run pipes underground, don't you?
That's it. Yeah.
It draws the heat from underground.
Yeah.
So does that work regardless of how the external temperature then? If you don't know, it doesn't depend
5 or 6 foot, isn't it?
Yeah. I mean the efficiency of it goes down as the external temperature goes down. Also, there's also the humidity of the air also affects it. But I mean I think with our climate it works well. Yeah.
I might have missed it, but does your system measure gas consumption as well as electricity?
Well, it can measure some gas meters because we don't actually, where we live, we don't have like a gas main, so we haven't really had the motivation to try and use it for gas. But some people have been using it with the sort of the pulse output, the flashing LED. I think some gas meters have that. But it depends sort of how new it is.
Yeah, I mean, that would be really useful.
Yeah.
If it could measure gas, I'd be asking you, can I buy one now?
Yeah.
Really, it's the more modern ones that have like the pulse output. We have had some that use it on some older ones, and they have little kind of a disc thing that it takes, and you can use a little Hall effect magnet sensor to detect them.
Yeah.
But they're a bit more tricky.
Yeah.
But there's all sorts. There's no sort of standardisation of gas meters. So
No.
it's quite difficult to make one thing that's just clip on every gas meter.
It's a microwave sensor.
I thought about gas flow, and I think you can probably do it using sound, can't you? In terms of temperature thing.
What do you get inside the tower?
Well, you ring it, and then you get a signal going really fast in the copper, and a slow signal going through the gas. So you just resolve it in time for me.
Which bit sense?
The outside.
You can get ultrasonic.
Yeah.
So,
Yeah,
Yeah.
that'd be good. I'm thinking about that one.
You two should get together. What about the range of your radio notes?
It's about
That's how thick the walls are.
yeah.
In like an old Welsh farmhouse is not that amazing if you've got thick walls of it.
About 10 15 metres through walls, maybe. Which is enough. If you've got the transmitter on one side of the house and the base station on the other side, it's usually alright. But if you've got something right down the garden or up on a hill, like a turbine or something, you might reach that.
What is the radio interface you're using?
It's a 400. Well, there's two. It's called the RFM 12. It's like 433 and 868 megahertz. Wireless chip transceiver.
Is that the same one that thermostats?
Yeah, and like doorbells and car
Is there a company called Radio
No.
the guys that used to work for Apple, I think, and they spun out. Well, we started up a company, and they're making little, basically, mobile phone type, SIM card type devices, which are wireless LAN capable.
SD card form factor.
Yeah, that's right.
Yeah.
It's a bit bigger, isn't it?
Yeah,
Oh, they're the SD card things.
yeah,
Yeah.
electric
Yeah.
inputs.
But they'll hook up to a wireless LAN,
Yeah.
sort of really easily. That'd be really cool if you had some audio and stuff.
Yeah.
Yeah, no, there's
Connected to
some
the
other forums
internet.
there about something like that. Because they're originally designed for uploading one application is uploading photos from a digital camera without taking the card out. He's managed to post for servers.
This isn't an actual SD card, it's in an
Oh,
SD
is
card
it?
form factor, but it has a wireless LAN and then a few GPIO chips and something that's, you know,
Yeah.
like a microcontroller inside.
It's got a few analog and digital bits, isn't it? It's quite general purpose. But they're just about to start shipping those in kit form, evaluation tool.
But the thing that, when you were talking about your CMS, and I was
Yeah.
wondering, I guess you would have looked at Patch Bay, or whatever that's changed the name now,
Yeah.
that kind of architecture of just uploading to the cloud
Yeah.
rather than loading into a local
Yeah.
sort of
Yeah.
store.
We're running a hosted version as well. At EmonCMS.org, so that's like sort of like an equivalent of being just posted online too.
Sorry, I wasn't hijacking the electric imp thing, because that has an architecture that is cloud based, so that supports, there's like some Amazon hosted service where you can have these devices around and drive logic from just a central server, and each node is sort of uplinked to the internet. There's another device, open source hardware one, which is called Ninja Blocks. They're called Ninja Blocks, and they got some funding through like Kickstarter or something. They're another the same architecture, cloud-based sort of logic, sensors and actuators, wherever.
And it's pretty similar stuff to that, I think. I mean, I guess they're another example of this kind of thing, where having a little sensor node, having a base station, uploading that. Yeah.
So, this open source hardware, what about using your devices in a commercial project? Is that, do you encourage that? Is it
Yeah.
not allowed, you know?
Yeah, no, it's allowed. It's allowed.
Yeah.
Well, we really encourage it. There's quite a few companies, we mentioned that heat pump guy, he's an independent consultant offering heat pump consultancy services. And our energy monitor is just like one tool that he uses to enable him to perform his job as a guy in Ireland who goes around monitoring the energy, offering energy consultancy to breweries where he goes in with all monitors and things, and there's the energy monitoring and advises them as how best they can optimise energy and things like that. So,
There's a mate of mine who does solar panels, it's his company installing them, and I've been talking to him, I've seen your website, and I'm just about to buy one actually, the system. But because it seems to be a lot of what he wants to do.
Yeah.
Is this diverting all power that you're not using in the house to heating or to a thermostat, a hot water tank.
Yeah. Right.
You know, that's the golden egg. You know, he reckons he can sell thousands of these things if you could get that power. You know, he's putting big systems in. All these people are wasting money by feeding it back into the grid. It's probably immoral because you're already getting the money. But you know, personally, that's where you get the most money back, isn't it?
Yeah.
Have you seen it or had any interest from anyone who wants to kind of productize it and make it into a consumer sort of thing?
There's some sort of a few. I guess we get approached by quite a few people, but I mean, it wouldn't really be something that we'd. I mean, at the moment, it's like the current version is like the through-hole electronics that you solder yourself, because as a kit. So the next stage is to make like a surface mount version that will be more ready to go. So in time we're going to be exploring, sort of doing sort of multi-avenue sort of approach. So both doing like a more commercial type product, which is ready to go and has all the right, or it's just something that will work off the shelf, and also that's also going to have the full hackability that that it always will have had. So it'll always be you will always be able to modify it as you need to do. Whether other companies will integrate it into their product, that'll be interesting to see what will happen.
How hard is it to set up right now? Is it easy or is it a lot of soldering?
Yeah, it's quite a bit of soldering. It's quite nice soldering. It's not. Yeah.
We've got quite detailed sort of step-by-step guides online of how to very broken down how to sort of set it up and go through all the necessary steps.
Okay.